Greetings, everyone. Today we are going to take a look at linear programming. What does that mean? What does it help us create or solve? I don't have any foldables or handouts, so you just need your notebook and your pencil and just keep an eye out for when you actually need to write down a few notes. When you get those notes ready, please don't forget to have that left column prepared so that when we look back and study, we've got some space. So first of all, let's talk about what is linear programming. So linear programming is a mathematical tool for maximizing or minimizing a quantity. Usually we talk in the real world about profit and cost. But when we deal with maximizing or minimizing a quantity, we're subject to certain constraints, so limits or restrictions. Take a moment to jot this down. Pause if you need to. So just a quick overview when we talk about profit or cost. In general, that sets up some constraints that we can maybe assume. So for example, if I'm talking about profit, my profit's never going to be negative, okay? Cost-wise, I could end up in the hole, but profit-wise, we tend to be above zero. So think about that on a graph. Where would that be? It'd be in the first quadrant. So then we talk about, if I sell or make this much, I make this much money. If I don't make as much, I don't make as much money. So just thinking about how that would look in the first quadrant. So most of the mathematical decisions made by management of businesses involve linear programming. So whether, of course, they don't call it linear programming, but when we talk about how much production will earn how much profit, but we don't want to produce too much because then we're not going to make money if people aren't buying the product quick enough. So a lot of different elements come into play, but we can generalize it or summarize it down to basic linear programming. When we talk about linear programming, we can think of it developed around the time of World War II. When we talk about rationing supplies, we have to consider population, we have to consider how much per group of people. All of that can be summarized down into a linear equation or systems of equations. It's also used in economics, manufacturing, production, planning, business management. Very real sort of way that I use it is in my photography business. So when I'm talking about planning mini sessions for a weekend coming up, I have to consider my time, how much editing that includes, how much profit would that yield, and my costs tend to be more of my time in that case. So how does that all work and plan together to where I'll actually make money that's worth my time? So let's go through a linear programming problem. You don't have to write this down. Let's just go through and get a sense of the idea of what we're looking at. So in this particular problem, we have a potter who wants to make and sell serving bowls and plates. A bowl uses 5 pounds of clay, a plate uses 4 pounds of clay, and the potter has 40 pounds of clay. He wants to make at least 4 bowls. So we're dealing with two unknowns, right? And I need to find out what would be the ideal for those unknowns. So we are going to say those unknowns we want to identify first. We're going to say X is the number of bowls. We're going to say Y is the number of plates. So always identify that X and Y unknowns first. So let's talk about the constraints. All of these bullet points are constraints. All right. So if I break it down, I know that I have a total of 40 pounds of clay. I know that that 40 pounds of clay can be broken up into 5-pound quantities for bowls and 4-pound quantities for plates. So pounds of clay plus pounds of clay is 40. We could use less than 40. So here's where the inequalities come into play. I don't have more than 40, so that's my constraint. I could use exactly 40 or I could use a little less. So I need to have an inequality and not an equation. And then I take a look at, I want to make at least 4 bowls. So X is my bowls. I want to make at least 4. So I could make more than 4. I could make exactly 4. But I can't make less than. So that's where that constraint comes in. And we actually have another constraint, even though it's not clearly written. Let's think about when we talk about plates. Y is the number of plates. Okay, I'm gonna make plates. So I need a constraint of y is greater than or equal to 0. I can't make negative plates. So I'm going to constrain this to that first quadrant. All right, so just make sure you should probably have at least 3 constraints. You're going to have more than that, but I'm just going to start off by saying at least 3. So if you don't see clearly 3, think about, can negatives be included? Do I need at least 0 or at least 1 in this scenario? So taking those constraints, the next step once you've created those is to graph. Graphing those inequalities is going to give us a region, and that region is going to tell us a lot of information. So the first thing I'm going to do is put this in a form that's a little easier for me to graph. So I'm going to put this into slope-intercept form, but it's up to you if you want to do point-slope form. You decide what's best. So that would get me down to 4y is less than or equal to negative 5x plus 40, which gets me to y is less than or equal to negative 5/4 x plus 10. Okay. If I go to graph that line, my y-intercept is at 10. I'm going to go down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, it's a negative line, so that makes sense. I'm decreasing. My line's negative. Go down 5 more and over 4 more. So there is my first line, my first constraint that I can see visually. Okay, look at our next one. We have x is greater than or equal to 4. X, it means it's going to go through the x-axis at 4. If it has to go through the x-axis, would it make sense to be vertical or horizontal? And it makes sense for it to be vertical. Ooh, horrible drawing. Sorry there. You get the point though. All right. Must be a little shaky this morning. Didn't have my coffee. So a vertical line through the value x is 4. And I'm going to take care of y is greater than or equal to 0. So if I'm at 0 on the y-axis, that's actually going to be a horizontal line. Y equals lines are always horizontal. If you forget that, think about y equals 2, right? It would go through 2 and it'd be horizontal. So if the 0 is throwing you off, just pretend it's a different number to get a sense of what that looks like. All right, so if I take a look at these constraints, I need to shade. So let's take a look at shading. I want y to be less than or equal to my diagonal line. So if I use a test point of 0, 0, that would mean I shade on this side of my blue line. If I take a look at my purple line, x needs to be greater than 4. So that means I would shade on this side. And then if I take a look at y is greater than or equal to 0, greater than 0 would go this way. Okay, so whether using colors or shading, what becomes clear and apparent is that the overlapping area occurs in this triangle shape here. Okay, now when I look at that triangle shape, I have some points that matter. All right, let's talk about that. I have this point here in the corner, this point here, and this point here. If I identify those points, all right, I have, it looks like 4, 0. I have 8, 0. And I have 4, 5. Is that 5? 1, 2, 3, 4, 5. Yes, make sure. Okay, so the region we just shaded in, we have a definition for that, and that's called the feasible region. That feasible region consists of all the solution choices for that particular program. So it means any point within there would satisfy my constraints, right? I could plug in, let's say 5, 1. I could plug in 6, 1. I could plug in 6, 2. anything within that is a feasible region. It's an option, okay? But really the big question is, how can I maximize my profit? When we're talking business, that's the whole point, right? We want to make some money. So if the profit of a clay bowl is $35 and the profit of a clay plate is $30, the equation we would use would be 35 times x plus 30 times y would give me my profit. So that makes sense, right? $35 per bowl, $30 per plate would give me a profit. Yes, there's a spelling error there, sorry. Would give me my profit, okay? So let's continue along these lines. How can I get the most money? In that case, we have to talk about points and which point is optimal, okay? Any point in the feasible region will satisfy my constraints, but would any point make me the most money? No, there's always a certain scenario that makes you the most money. So we call it the corner point principle. In linear programming, wow, I can't talk. In linear programming problems, the maximal value for profit always corresponds to a corner point. So we identified those on the graph. We said, here's a corner point, here's a corner point, here's a corner point. So those corner points matter, okay? So we want to use these corner points to determine which one gives us the max profit. All right, you can make some assumptions. Sometimes you're going to look at a point and say, no way is that going to get me max profit. All right, but sometimes you might be surprised. So using those 4 points, let's plug that into our profit formula that we already created. So our profit formula was P 35x plus 30y. Plug each point, okay, into that profit formula we created. So when I plug in 40, I get $140. When I plug in 80, I get $280. When I plug in 45, I get $290. Ooh, these are really close. So if you would have looked at the graph, you might not have been able to assume either of those. So in this case, we would say 45 is my optimal point, right? It gets me the most money. It's the best point on that whole graph. So we would say to make the most profit, the potter needs to make 4 bowls and 5 plates. Okay? Could they make a different combination? Yes, but this will get us the most profit by $10. So to summarize, let's take that example and let's summarize that into some steps. So we definitely want to add these to our notes. So first step is just to read through the problem, get a sense of the scenario, understand the context of which we're talking about. Second is to set up inequality constraints, okay? You're gonna have 3 or more constraints. So those are gonna be your linear inequalities, right? So I'm gonna have 3 or more line inequalities. Just think about that. We then want to write a profit or cost formula. So we're looking for either the highest profit or the lowest cost. So sometimes you want the highest number, sometimes you want the lowest. Graph the inequalities so you can find that feasible region. And then once you have that feasible region, use the corner point principle to find either the max or the min. So very generalized steps. I would say, to be honest, the most work is just going to be the graphing piece, okay? Once you've got those points, plugging them in, that's mental math. That should go fast. I'm going to say the toughest step is making sure to set up those constraints correctly. So just be careful with those constraints. Make sure they make sense. Make sure you have enough information, and check with a neighbor on those. So in preparation, just make sure that you have these notes completed. If you need to stop or rewatch part of the video, please do so. If you have anything missing, make sure you take care of that. And think ahead just to the next learning check. Where are we at? What do we need to work on? And if you have any questions, just let me know. See you next time.